All right, so on your quiz on Monday, you're going to have 3 questions that are in exponential form that ask you to do all of these things, and only 1 out of the 3 is going to ask you to graph, and we're going to give you the points to plug in to graph it. You're going to have 1 question where you have to find all of these things to do the log. You don't have to graph the log one. You're going to have 3 questions that ask you to put it in exponential form and evaluate. You'll have 1 that you have to solve using the one-to-one property, and then you'll have 2 questions with compounded interest. So there's kind of a lot of questions, so you guys just have to make sure you know your stuff so you can work diligently for your quiz. So I want to do number 1 over again, just because yesterday was not great. So always, for exponential functions, our domain is going to be all real numbers. So always, 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 we have negative infinity to infinity. Our range always involves this number out here. So this number tells us what our range and our horizontal asymptote are going to be. So that vertical shift that we have on the outside determines our range and our horizontal asymptote. For this one, our graph, what did we say it looked like yesterday when we plugged in numbers? So what would our range be here?
Negative infinity to -1.
Negative infinity to -1, perfect. This number here always tells us our range and our horizontal asymptote. So what do you think our horizontal asymptote is going to be?
Y equals -1.
Y equals -1, perfect. For our intercepts, we're always going to plug in 0 to our equation and solve. So for our y-intercept, that means we plug in 0 for x. So we have -2, negatives on the outside, so -2 raised to the power of 0 plus 6 minus 1. So this is -2 to the power of 6. 2 to the power of 6 is what?
64.
64, so this is a -64 minus 1, so -65. So our y-intercept, we plugged in 0 for x, so it's -65. 0, -65. And then our transformations, we're just going to look at everything that's happening in our equation and write our transformations about it. So a negative out front tells us what?
Tells you it's a reflection.
A reflection. On which axis?
The x.
The x-axis. What about the +6 next to the x?
Shift to the left.
Left 6. And then the -1?
Down 1.
Down 1. So all of these transformations here, you can have your sheet that has all the transformations on it. So you can just look at your sheet and determine where it's going to go. So remember, you guys can have a piece of paper with notes on Monday. So all of the transformations, you can just check out your sheet and see what's happening. Okay, so this is everything for this one. Any questions on number 1?
Are we gonna have to graph the transformation like the new one?
No. You only have one where you have to graph, and it'll tell you plug in -2, -1, 0, 1, 2. Just plug in those numbers, find your y values, and graph all of those points. So the one that you have to graph, it tells you what to plug in, and you just graph the points. All right, let's look at number 2. So again, what's our domain? All real numbers, so -infinity to infinity. What's our range going to be?
1/3 to infinity.
Remember, the number that's being added out here tells us what our range and our horizontal asymptote are. Do we have a number being added out here?
No.
No. So then our range and our horizontal asymptote don't change from our parent function. So our range is going to be 0 to infinity. And our horizontal asymptote is what?
Y equals 0.
Y equals 0. So only when you have a number outside that you're adding or subtracting, that vertical shift up or down, that's when you're going to have a change in your range or your horizontal asymptote. How do we find our y-intercept?
Plug in 0 to the x.
Plug in 0 to x. So we have 1/3 times 2/3 raised to the -2 times 0 plus 1. So this is 1/3 times 2/3 to the power of 1. So then we just multiply our fractions together. So we multiply the tops and multiply the bottoms. So we have 2/9. So how would we write our y-intercept?
You write 0 2/9.
0 2/9. So since we plugged in 0 for x, 0 comes first, and then 2/9. Now we can look at our transformations. So we have this 1/3 on the outside. What does this tell us?
That it's shifting up.
So multiplying a number, it's either going to be a stretch or a shrink, or vertical or horizontal. So when it's out front, it's what? To the left one. All right, so I made like a little exponential functions 101, let's say. Exponential functions for dummies. Not calling you dummies, just like how the book says. Domain is always going to be all real numbers, but you guys write it in interval notation, so -infinity to infinity. The range. The range of our parent function is always 0 to infinity. If we have a reflection like we had in number 1, it would be -infinity to 0. But what changes here is when you have a vertical shift. So you add the vertical shift here. So if you don't have a vertical shift, it'll stay as 0, but like we had in number 1, we had that -1, so our range went from -infinity to -1. Our horizontal asymptote is always going to be this same number. So y is equal to that number, and again, we add the vertical shift, whatever that is. Yes?
So if the vertical shift is negative, then we
It would only be negative infinity if you have a reflection. So like for this one, our graph had a reflection, so it goes down to negative infinity. So anytime you have a reflection, that's when it would be negative infinity to that number. But you guys won't have to worry about that for the quiz. So it'll always be, you just add the vertical shift to infinity. Okay, and then lastly, we have the y-intercept. We plug it in. And then the transformations, you look at your sheet. So this is exponential functions 101. Any questions? Are you ready to move on to log functions? And when I say plug in, I mean plug in 0 for x. So if we had one that was, let's say, 1/3 times 2x, 2 raised to the power of x, plus 3. What would our range be here?
3 to infinity.
3 to infinity. What would our horizontal asymptote be here? Y equals 3.
Equals 3.
Perfect. So this number out here always tells us the range and the horizontal asymptote. Okay, let's move on to our log functions. So you're going to have one like this on the quiz on Monday. Here, our range is always all real numbers. So always, 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 our range is all real numbers. Our domain is going to be 0 to infinity unless we have something going on in these parentheses. So in the parentheses, we want to set 4x plus 1 equal to 0. This is going to give us our first number in our domain and the vertical asymptote. So we solve for x, subtract 1 on both sides. 4x is equal to negative 1. Divide by 4. X is equal to negative 1/4. So this is our first number in our domain and our vertical asymptote. So x is equal to negative 1/4. And since we don't have a reflection here, it's negative 1/4 to infinity for our domain. So remember, our graph looks like this. If we had a reflection on the y-axis, our graph would look like this. So yeah, our domain would be negative infinity to negative 1/4. No. Okay, next we have to find our x-intercept. X-intercept, we plug in 0 for y. So we have 0 is equal to log base 3 of 4x plus 1. Now it's hard for us to solve in log form. What can we do to make this a little bit easier?
Put in exponential.
Put it in exponential form. So our base goes down to the middle, 3, it's equal to, when we switch the left and the right. So 4x plus 1 is equal to 3 to the power of 0. I'm going to move it over here so I have more room. What's 3 to the power of 0? 1. Anything to the power of 0 is 1. So we have 4x plus 1 is equal to 1. And we just solved for x, so subtract 1 on both sides. 4x is equal to 0. Divide by 4. X is equal to 0. So our x-intercept is 0, 0. All right, let's look at number 4. So what's our range going to be? All real numbers.
All real numbers.
So negative infinity to infinity. How do we find the domain and vertical asymptote? Set
You
the
take that
parentheses.
2x minus 7 and then you set it to 0.
Awesome. Set the parentheses equal to 0. Add 7 to both sides, divide by 2, so you get x is equal to 7 over 2. So what would our domain be? 7 over 2 to infinity. And what's our vertical asymptote? X equals 7 over 2. Now our y-intercept. How do we find the y-intercept? I mean the x-intercept, sorry. Set the equation equal to 0. So 0 is equal to log base 2 of 2x minus 7. We need to put it into exponential form, so I just drop the 2 down. Take what's on the right, put it on the left. Take what's on the left, put it on the right. So 2x minus 7 is equal to 0 to the power of 2. 2 to the power of 0. What's 2 to the power of 0? 1. So 2x minus 7 is equal to 1. We add 7 to both sides. So 2x is equal to 8. Divide by 2. X is equal to 4. How would we write our x-intercept? 4, comma,
4,
0.
0.
Yep. Okay, so I made another one. Log functions 101. Our domain is always going to be the same as the vertical asymptote to infinity. Our range is always, always, always all real numbers. Negative infinity to infinity. Our vertical asymptote, we set the parentheses equal to 0. And our x-intercept, plug in 0 for y. So next we are rewriting an exponential form and evaluating. So I always like to put this on the left side. Miss Meadows does it on the right side. So all the questions on the test have it on the right side. Do you guys like it better on the left? Because I can change the questions on the quiz. Or it doesn't matter? Doesn't matter. Okay. So bring down the base. I move this to this side. So 1 over 64 is equal to 2 to the power of x. So now I need to get 1 over 64 to look like a 2. How can I do that?
Negative 6.
Perfect.
X equals negative 6.
So 64 to the negative 1 gives us 1 over 64. So first we have to make it negative. And then we know that 64 is 2 to the power of 6. So we need it to be 2 to the power of negative 6. And this is equal to 2 to the power of x. Once our bases are the same, we cancel it out. Negative 6 is equal to x. Any questions here? All right, number 6. So bring the 81 down to the middle. X goes on this side, 1/2 goes up top here. So I have x is equal to 81 to the 1/2 power. What is the 1/2 power?
Is it like the it's 9?
Like 6 people online said the same thing, but it is the square root. So the 1/2 power is the same thing as the square root. So it's the square root of 81. So yes to whoever said, is it 9? It is 9. So x is equal to 9. Any questions on that one? Okay. Next, for number 7, I'm going to move the 3 to the other side. So I have 7 raised to the power of 3 is equal to x. This we just have to do 7 cubed. Which remember guys, you can use your calculator on Monday, but you just can't use your iPad or phone as a calculator, so you need a real calculator. 7 cubed would be 343. Any questions on these? All right, you're going to have 1 using the 1-to-1 property. So when our bases are the same, we can cancel them out and just set the exponents equal to each other. So x plus 3 is equal to negative 6x minus 3. And then we just solve for x. So I'm going to add 6x to both sides. So 7x. I'm going to subtract 3 on both sides. 7x is equal to negative 6. Divide both sides by 7. X is equal to negative 6 over 7. Any questions here? All right, number 9. So we need our get.
Is it just solving for x?
Yep. Once our bases are the same, we can cancel out our bases and just solve for x. So here we need to get our bases to be the same. We can't get 27 to look like 9, but we can get them both to look like a 3. So how do we get 9 to look like 3?
You square
So
3.
3 squared. We have to multiply that times the 2x up top. And then how do we get 27 to look like 3? 3 cubed. And then we have to
You cube it.
multiply that times the 2x minus 4. So once our bases are the same, we can cancel them out. So I have 2 times 2x is equal to 3 times 2x minus 4. Here we have 4x. And then here I need to distribute. So I have 6x minus 12. I can subtract 6x on both sides. So negative 2x is equal to negative 12. Divide both sides by negative 2. So x is equal to 6. So from here, it's just basic algebra solving for x. Ready for number 10? Yeah. Okay. So can we get 8 to look like a 4?
Yes.
How?
Or you can, well, no, you can make 1/4 look like an 8. Or,
Okay.
no, try to make them have like a common.
We can get them
Never
both to
mind,
look
never
like a
mind.
2. So how
I
do,
thought since 4 and 8 both go to 64.
you could do that too, but you would have to, it's easier to make it smaller because 8 is 2 cubed. If we changed it to 64, we would have to, instead of multiplying up top, we would have to divide. So it's easier just to find like the smallest base that's in common. So we have 2 cubed, which is 8, so then we have to multiply this to 3x plus 2. So we want this 1/4 to look like a 2. How can we do that?
So it would be 2 times -2. I mean 2 to the power of -2.
2 to the power of -2x. Perfect. So now our bases are the same. We can cancel them out. -2x is equal to, I'm going to distribute. So this is -9x plus 6. I can add 9x to both sides. So 7x is equal to 6. Divide both sides by 7. X is equal to 6/7. So for all of these questions, since we're talking about money, we want to leave with 2 decimal places. Okay, we have 5 minutes left, so I wanted to do the compounded continuously one. So here we have our APERT formula. So A is equal to P times E to the power of RT. So our P is the same, 24,500. Our E is just a button in our calculator. Our R is 0.027, and T is 4. So first we need to do 0.027 times 4. So we have 24,500 times E raised to the power of 0.108. Click that E raised to the X button. So 24,500 times 1.11404. $27,294.17.